My name is Kanaan Seeballack from class 8-2. The title of my science fair project is Burning Coal. So in this experiment we'll be testing what temperature of water has the fastest rate of weathering. So the research question for this experiment is, how does water temperature affect the rate of weathering? The hypothesis is, if cold water beats down on a calcite rock for a steady stream of water, the surface of the rock will freeze, making the rock easier to be broken down. So to conduct the experiment, my materials were a triple balance beam that ended up being a scale, a water hose that turned out to be a faucet to control hot or cold water, a calcite rock, a pen and paper to record my results, a container to place the rock, and a thermometer to take water temperature. So the independent variable was the temperature of the water. The controlled variables was the temperature of the room, the type of rock used, which was a calcite rock, and the dependent variable was the amount of rock weathered. So for the procedure, you take one calcite rock and place it on a scale, and you put that as your starting amount. You take it out and put it under a stream of cold water. You take it out, after 1 minute, you take it out and put it back on the scale. That's the amount left. You do that until it reaches 10 minutes. So in the end, my hypothesis was refuted. As you can see by my graph, the orange line represents the hot water and the blue line represents the cold water. In that the orange line reached, by minute 4, for all 3 trials for the calcite rock under hot water, there was no rock left and it had completely dissolved. But by trial 9, it had completely dissolved for cold water. So the way that this can be applied to science is to help archaeologists whose main job is to preserve fossils that you can't just move to a museum or throw a tarp over. So now that they know warm water weathering is able to weather artifacts or statues faster, they can find ways to prevent it. Thank you.